Hello everyone. In this video, we'll be looking at the solution to problem 1 from part 1 of Irodov. The book we are looking at is Problems in General Physics by I.E. Irodov, one of the most important books for a IIT JEE aspirant or an NEET aspirant to be able to solve. Part 1 deals with mechanics, and we are looking at the first problem, which is a kinematics problem. As you can see, the problem is given on the screen. A motorboat going downstream overcame a raft at a point A. At a time tau is equal to 60 minutes later, it turned back and after some time passed the raft at a distance L is equal to 6 kilometers from the point A. Find the flow velocity, assuming the duty of the engine to be constant. So in this question, they're asking us to find the flow velocity, which is the velocity at which the river is flowing. They're also assuming the duty of the engine to be constant, which means that the speed of the motorboat in still water will be constant. The speed of the motorboat with respect to the river, either going downstream or upstream, is going to be the same. So let's start by solving. First, we'll make a rough diagram. Let's say this is the motorboat and this is the raft. Since the raft by definition will not have any power, the raft will be flowing at the speed which is equal to the speed of the river. Let speed of river, we'll assume, equal to VR, and speed of motorboat in still water, we'll assume that equal to V motorboat. So when the motorboat is going downstream, the speed of the motorboat relative to the ground will be equal to the sum of the speed of motorboat in still water plus the speed of the river. And upstream, the speed of the motorboat when it is going against the flow of the river will be equal to speed of the motorboat minus speed of the river. These two are essential for us to solve this question. Now, in the first part of the journey, let this point be A, where the motorboat has overtaken the raft. In the first part of the journey, we are told that the motorboat, once it overtakes the raft, travels for a time equal to 60 minutes or 1 hour. The distance is not yet given. Let's call this D1. Afterwards, it turns back and starts back on the journey and arrives again to meet the raft at another point which is 6 kilometers downstream. Let's call this point C. This point is 6 kilometers downstream. The raft, motorboat. So this distance between the second meeting point and where the boat has turned around will be equal to D1 minus 6. Let's assume the motorboat traveled for a time equal to T. So we will have three equations forming now. First, the motorboat has traveled a distance D1 in a time equal to tau. at a speed of VMB plus VR. This gives me, now we know that the distance is equal to speed into time. Using this formula, I will get d1 is equal to tau into VMB plus VR. Given that I'm converting everything to kilometers per hour, I will change tau equal to 60 minutes into 1 hour. So d1 is equal to VMB plus VR. This is my first equation. The second equation, the motorboat has traveled for a time t upstream and covered a distance of d1 minus 6 in time t at a speed of VMB minus VR. So this gives me the equation d1 minus 6 is equal to time t into VMB minus VR. I still don't know time t. I don't know the V motorboat, nor do I know VR. However, I know from 1 that d1 is equal to VMB plus R. I will substitute that in equation 2. d1 in equation 2 to get VMB plus VR minus 6 is equal to VMB minus VR times t. This will be equation 3. And finally, I know that in the time that it takes the motorboat to go from A to B and come back to C, which is equal to tau plus t, the raft has covered a distance of 6 kilometers from A to C. So using that, I will create a new equation. 6 kilometers distance of the covered by the raft is equal to the speed of the raft, which is equal to the speed of the river, into the time tau plus t. So 6 is nothing but VR into 1 plus t. Remember, we are changing everything into kilometers per hour and hours and kilometers. So tau, which is 60 minutes, becomes equal to 1. Or 6 is equal to VR plus VRT. This is equation 4. Now, if I substitute equation 4 into equation 3, substitute equation 4 into equation 3, I will get, in the place of 6, I will substitute VR plus VRT in equation 3. Equation 3 says, this is my equation 3. And I'm substituting this equation 4 into equation 3, which will give me VMB plus VR minus VRT is equal to VMB T. I'm opening the brackets on the right hand side, minus VRT. These two get cancelled. Minus VRT gets cancelled on both sides, which gives me VMB is equal to VMB times T, or T is equal to 1 hour. Once I get this, I will substitute this value into 4, which gives me 6 is equal to VR plus VRT, or 6 is equal to VR plus VR. 6 is equal to 2 VR, implying speed of the river is 3 kilometers per hour. Why did we get kilometers per hour? Because we converted all the units into hours and kilometers, and the corresponding speed kilometers per hour. This is what we are required to calculate, giving me the flow of the river, the speed of the flow. I'm required to calculate the flow velocity. That is nothing but 3 kilometers per hour. That is my answer.